Number 4, little bit more complex. There's lots of backstory that I kind of want to provide for you. But in chapter 4, or worksheet 4, it says find the zeros of the quadratics by factoring. And that's kind of confusing. And we have this polynomial, this trinomial. And as we've seen before, we know that when we multiply two binomials, that we create a trinomial. This 3-term is produced or can be factored. If we go in this direction, it's called factoring. If we start with this trinomial and turn it into a product, we call that factoring. Much like if we have 24, factors of 24 can be 2 and 12. So we turned a term into the product of something. So if we are given this 3-term and turn it into a product of something, that's called factoring. When we go in this direction, when like in worksheet number 3, when we're given two binomials and it says to simplify, and we simplify by foiling or the double distribution, we would end up creating this. So very important that we understand both of the states. When it's in this state, it's factored. When it's in this state, it's been simplified. So I want you to understand when it says what are the zeros, because we're going to turn this into the product of two numbers. And what do we know about two numbers when multiplied? Let's do this. It's a good little aqua color. If we have two boxes, two unknowns that are multiplying each other, that produce 0, what do we know? That one of these must be 0. That's the only way you can get 0 through a product of two numbers. No numbers, 2 times -2 does not equal 0. That equals -4. 5 times 1/5 does not give you 0, it gives you 1. Even if you do a negative, that would be -1. So those don't produce 0. The only way you can produce 0 is when you have 5 times 0, that equals 0. Give me another example of what produces 0. 0 times -7, that equals 0. Every single situation where you have a product of two numbers that equals 0, one of them must be 0. So we know that if we can factor this into a product of two binomials, that we can figure out which one of those is 0. So the first step that we need to do is we have to factor this trinomial. And that is a whole nother ball of wax that we haven't learned and you haven't been taught yet, because that's later on in the year. But we will try to do that. So I'm going to teach you this process. So we know that it's going to be the product of two binomials. All right, something times this first times first is going to produce this. This last times the last is going to produce your last. And your middle term is going to be the sum of the outside and the inside. Remember, this is a product, your inside is a product, your outside is a product, and then we're going to add them together, and that gives us our middle term. And herein lies the difficulty of jumping this quickly into academic decathlon material without building the base. We have done 0 building of the base. We touched on it a little bit in worksheet 3. So you have quite the daunting task. So we have 4x squared plus 8x minus 5. So this is in the form of ax squared plus bx plus c. 4 is my A value, 8 is my B value, and -5 is my C value. And it equals Y if we wanted to put it in a quadratic equation. And it is in a quadratic equation. So right now my Y value is 0. And there's a whole bunch of things that we can discuss about that with parabolas and what that looks like. But I divert. So I am going to, there is a method called A times C. We're going to take the A value and multiply it by the C value. My A value is 4, my C value is -5. And 4 times -5 is -20. So I'm going to find factors of 20. 1 and 20, 2 and 10, 3 no, 4 and 5. I don't have to go anymore because 5 through 20 have already been picked. So that's the first thing. Now, the product of these two numbers need to equal -20. So I don't know if it's -1 and +20, or is it +1 and -20, because the product of these two numbers has to equal -20. So one has to be positive, one has to be negative. That's the only way you can get a negative through a product. So in order to find out, I look here. And that first sign tells me that the bigger of these two product numbers, 1 and 20, is going to get the positive. So 20 is going to get the positive. 10 is bigger than 2. 5 is bigger than 4. And so if this is positive, in order to multiply these two numbers, this has to be a -1, because -1 times +20 will give me my -20. And if this is +10, then this needs to be -2, this needs to be -4. And now, just when you thought that this was simple, I know you didn't think this was simple, but just when you think it's simple, I'm going to erase this. Now we're going to combine these two numbers. -1, we're going to add and subtract. -1 and +20 is 19. -2 and 10 is 8. -4 and 5 is 1. So I want to know, of these additions, of this sums, which one equals my middle? Which one's equal to my middle? -2 and +10. So I'm going to turn this trinomial into a polynomial or a quadnomial. -2x plus 10x minus 5. And you go, what? Where'd you get those numbers from? I got those numbers from -2 and +10 from here, because -2 and +10 makes 8. So if we combine -2x and +10x, notice it was just a different way to write 8x. We are reversing the foiling process. We're not going to go back to foiling, but we're reversing this process right here. So now we've turned 3 terms into 4 terms. And now we're going to do what is called factor by grouping. We're going to group the first 2 and the last 2. And we're going to look for a common factor. So what is a common factor amongst 4x squared and -2x? 2x. Very good. Both have 2x. If I factor out a 2x from 4x squared, that leaves me with 2x. If I factor out a 2x from -2x, it leaves me with -1. Let's look at the other pair, 10x minus 5. So we're going to look for a common factor. What is the common factor? A +5. If I factor a 5 from 10x, I get 2x. If I factor out a 5 from -5, we get -1. And here is our first time to check and see if we've done it right. I will tell you that if you did it right, the 2 terms inside the parentheses are the same. They must be. They must be the same. If you did it right, those 2 have to be the same. We're going to pull those 2 out. If I remove the 2x minus 1 from both of these, and if we cover it up, we cover it up, oh good, we're still purples. If we pull both, oh, that wasn't very good. If we, oh gosh, why aren't you working? I hate the smartboard sometimes. If we, I swear, this is where my patience goes. If we pull, wish the pen would work. No, we don't want that. This is, I'm losing your focus. I know. Whatever. If we pull the 2x from both of those, I'm giving up. Sorry, Mr. Mac is defeated. It's Friday. So if we pull out the 2x minus 1, the two yellow things out, what are we left with? We're left with 2x plus 5. So 2x plus 5 equals 0. I forgot to put the equals 0 in there because that's what our starting problem says. But that's what we're factoring. We're factoring that left side. And now we have two boxes. So if we multiplied 2x minus 1 times 2x plus 5, we would have gotten 4x squared plus 8x minus 5. So that's factoring. And now we have two boxes that equal 0. So this has to equal 0 or this box has to equal 0. So what we do is we separate and we say, okay, if this has to equal 0, what is my x value? So we just solve for x. 2x minus 1 divided by 2, and we get x equals -1/2. And then if we set this one and we say, hey, what x value would make that box equal to 0? So we subtract 5, we get 2x equals -5 divided by 2 divided by 2, and we get x equals -5/2. So the way that we write our solutions are in solution sets, and we always put it in numerical order. So my two zeros, the two values that would make that problem 0 is -5/2. Did I make a mistake somewhere? I did make a mistake. I know. You saw it. Such a bad day. Such a bad day in this smartboard. That needs to be plus. That's a plus. That's a plus. So sorry. That's a -1. Sorry. You saw that. At least my order is still correct. So those are the two values. If we plugged it back into that starting problem, if we plug in 1/2, let's do it just to show you. 1/2 squared is 1/4. 8 times 1/2 gives us 4. 2 in the denominator. And 4 times 1/4 is 1. And 1 plus 4 is 5. And 5 minus 5 is 0. Bing! So that 1/2, when x equals 1/2, produced my 0. Yep. And then if we plugged in -5/2, that would also produce it. Oh, this is just the beginning, kids. All right. The second one. Anybody remember what type this is? I call it dead on the street, DOS. This is the difference of squares. So what produced this? What two binomials produced that? Remember, what do they have to be in order to produce difference of squares? Conjugates. Yes. Did you remember that from section worksheets 3? Yeah, we're going to have conjugates. So the difference of squares, we're going to take the square root of our first, will always be our first, and the square root of our last is always going to be our last. And what do we know about our signs? They have to be opposite of each other because they're conjugates. And notice our inside and outsides would cancel. That's 6x and -6x. That's why we don't have a middle term. And so that's a really nice, efficient way. What were the characteristics of the difference of squares? The difference of squares is going to have three characteristics. First of all, it's always going to be two terms. Two terms. This is two terms, x squared and negative 36. It's always going to be subtraction. It's always going to be subtracting the two. That's another characteristic. Subtraction between the two. And then the third one is the first and third, technically first and third. That's the third term. Or both. Oh, let's do this. No, let's do both. Both are PS I love you, or perfect squares. So these are both perfect squares. X squared is a perfect square, 36 is a perfect square. So in order for it to be the difference of squares, those three things have to happen. Two terms, subtraction, perfect square, perfect square. If those adhere, then we can turn them into conjugates by taking the square root of that and take the square root of that and put those in my lasts, my first and last, and you will produce it. Now, it's equal to 0, so we have two boxes multiplied that equals 0, so we set each one equal to 0 and solve for it. So we're going to subtract 6. We get x equals negative 6. Add 6. X equals 6. So my two solutions are negative 6 and 6. Those are my zeros. Another way you will see in high school is they will use this term, plus or minus 6. You see that on your calculator sometimes. The plus or minus right here, right up here, that's the plus or minus. So that's a more efficient way, a high school way of writing negative 6 and positive 6. And those are the solutions to that. So the question, is this the difference of squares? One of the things that should go off in my head are, first of all, the reason why I asked that is because there's two terms. Wow, difference of squares is two terms. And the other big bell ringer should be that subtraction, because every difference of squares has two terms in subtraction. So we know that two of the three are already okay. So two terms. Check. Yes, two terms. Is it subtraction between the two terms? Yes, subtraction. And then the third characteristic is, why would they do that? Is, are they both perfect squares? So 49 is a perfect square, x squared is a perfect square, so this term is a perfect square, and 81 is also a perfect square. We should know perfect squares up to 15. I think I talked about that in worksheet 1 or 2. So yes, they're both perfect squares. So we know that they're going to produce conjugates. One's going to be plus, one's going to be minus. And so we take the square root of 49x squared, which is 7x. And those are going to be my first in both of my binomials. And then the square root of 81, which is 9. And those are going to be the lasts. And I know that the product of two boxes equals 0. We know that 7x plus 9 must be equal to 0, or 7x minus 9 must be equal to 0. And notice they're asking you to factor. Let me see if it asks you to solve. Hopefully it asks you to do the same thing. By factoring, good, and by factoring. Excellent, okay. Because sometimes you can isolate, solve for the variable. But we're not doing that in this. This is much more efficient. Minus 9, you get 7x minus 9, divide by 7, x equals negative 9/7. You're going to add 9, 7x equals 9, divide by 7, x equals 9/7. So I can write it in either way. I can either write it long-winded, or I can write it really efficient, plus or minus 9/7, which means plus 9/7 or negative 9/7. Cool. All right, also by factoring. So this is A times C. It's three terms. So I'm going to do A times C. What's my A value? A is the coefficient of c squared. Remember, it's in this format, ax squared plus bx plus c, where a is the coefficient of my x squared, or my variable squared, not 4, but you know, right there. And then b is going to be the coefficient of x, or my first degree variable. And c is going to be my constant. So what are my a and my c? So a is 1, and c is 25. So that gives me 25. Factors of 25 are 1 and 25. 2 no, 3 no, 4 no, 5 and 5. Now, my signs, positive. What gets positive? Well, positive times a positive makes, or a negative times a negative makes a positive. So I have to figure out what are my signs. You're going to cheat here because remember, we're going to add and subtract, and it's going to equal my middle term. So the only way I can get a negative is if both of these signs are negative. Remember, they have to be the same because that's the only way through the product you get a positive number. Either positive times a positive or negative times a negative produces the positive 25. But because my middle is a negative and I'm going to combine these, I'm going to combine them. The only way I can get a negative is if those signs, if they were positive, it would have produced a positive 10, and that wouldn't equal my middle. So I see that my two terms, I'm going to split that middle into 2. I'm going to turn this 3 term into 4 terms. Minus 5c minus, that's a horrible minus 5c plus 25 equals 0. Because remember, negative 5c and negative 5c makes this negative 10c. So that works. If I simplify it back upstream, it better still equal. So now I'm going to factor by grouping. I'm going to group the first 2. And I'm going to look for a common factor of c squared minus 5c. They both have a c. So if I take a c from c squared, that leaves me with c. If I take a c from negative 5c, that leaves me with negative 5. I'm dividing that into it. Now, let's factor the next group. I know you look at it, and we have to be aware that our first term is negative. When our first term is negative, we must factor out a negative in that GCF. So negative 5c and positive 25, I can factor out a negative 5. So if I divide negative 5 into negative 5c, I get c. If I divide 5 into positive 25, I get negative 5. How do I know if I did it right? Remember, these inside the parentheses must be identical. That is my indicator that I did it correctly. So in this case, I did do it correctly. I'm going to pull out that common factor, and what does it leave me with? It leaves me with c minus 5. So that's the other binomial that I get. And look at that. That's the same term. It's okay, but now we have 2 boxes that equal 0. So we're going to separate each one. C minus 5 equals 0. C minus 5 equals 0. We're going to add 5, C equals 5, add 5, C equals 5. So my solution is just 5. We don't have to write it twice because it would be the same exact answer. So that would be the solution to number 4. And this is going to be the longest video I've ever made in my life. Okay, we got it again. Here we go. We can use A times C. That's a beauty. When you get better, you're going to notice that that is a binomial square. But we won't get into that just yet because we don't have the time to do that. That's a whole nother video that I will show you that I have in my library of videos. But what is my A value? 4, good. What is my C value? 9, excellent. 4 times 9 is 36. Let's do factors of 36. 1 and 36. 2 and 18, 3 and 12, 4 and 9, 5 no, 6 and 6. What are my signs? Are they both positive or both negative? Because remember, if this is a product and it's positive, they must be either both positive or both negative. That's the only way I can get a positive. So what's my indicator? My indicator is the sign in the first. What is my middle value? It's a positive. So I know that both of these must be positives. So when I combine them, when I add them, I get 37, I get 20, I get 15, 13, and 12. Which one of these is equal to my middle value, 12, right here? So I'm going to take these two values and I'm going to split that 12y up, and we get 4y squared plus 6y plus 6y plus 9 equals 0. How did I know it was y? Because remember, we're adding those two outside and insides to get that middle term. And now we're going to factor by grouping. So we're going to group the first two, we're going to group the second two. What is the common factor of 4y squared plus 6y? That would be 2y. If we factor out or divide 2y into 4y squared, we get 2y. If we factor 2y into 6y, we get 3. Now we look at our second pairing, 6y and 9. Well, there's a common factor of 3. 3 goes into 6y, 2 y's, and 3 goes into 9, 3. How do I know I got it right? Because these are identical. They have to be the same. They are. Let's pull that out. If we pull it out, what are we left with? Oh my, 2y plus 3. Another one like that, 2y plus 3. And that is because it's a binomial square. We'll deal with that later. So let's separate each one. One of these must be equal to 0. So what value for y makes that 0? And what value for y makes this 0? Negative 3. 2y equals negative 3. Divide by 2. Y equals negative 3 halves. Minus 3, 2y equals negative 3. Divide by 2. Y equals negative 3 halves. So it's the same solution, so we just have to write it once. That's a horrible 3, so let's rewrite it. Good. Perfect. Another single solution. All right. So let's start going into things that we have to think about before we do that factoring stuff. And this is sort of the things that I would teach you in succession in a normal, regularly based class. The first thing we have to make sure is make sure that this equation is set equal to 0, because it's coming. This is not going to be equal to 0. So first thing is make sure it's set equal to 0. I'm going to guess that the next problem is not going to have a 0 there, and it's going to make me look really smart. Or should I say smarter? All right, second thing, is there a common factor amongst the three terms? Is there a common factor that we can factor out before we do any factoring A times C? So that's why I introduced that. Yeah, there's a common factor of 3, so we can factor out that 3. Again, there is no common factor. I thought there was going to be a common factor, but that's still important. And there is no common factor. Sorry. There is no common factor. So the next thing is going to be, is it a special case? Is it a binomial square, or is it the difference of squares? And we'll go into those a little bit later. And then 4 is, can we do A times C? And that's what we're going to use in this case, because it is not a special case because the first and the last are not perfect squares. So the first criteria in binomial square or difference of square is both have to be perfect squares, and then we can go from there. But since these are not perfect squares, that's going to take us to factoring technique number 4, which is A times C. A is 3, C is 45. That's going to be a big number. 15, so 145, 12, no, 135. 45 times 3. Let's just take our time. 45 times 3 gives us 135. Good. Now we have to find factors of 135. Barf-a-roni. 1 and 135. 2, no. 3, yes. 3 and 45. 4, no. 5, yes. 5 and 27. 6, no. 7, no. 8, no. 9, yes. 9 and 15, and that's it. So we have a positive number, so we know the signs are going to be the same. And we look here to see, since my middle term is positive, I know that the signs are both going to be positive. 136, 48, 32, and 24. Which one of those is equal to my middle? 32. So that's my middle. So I know I'm going to break them into those two numbers, 5 and 27. So I'm going to have 3x squared. This gets broken up into 5x and what we say, 27? And 27x plus 45 equals 0. We're going to factor by grouping. Let's look at the first two terms, 3x squared plus 5x, no coefficient in common, but they both have an x. So let's factor out an x. We get 3x plus 5. Let's look at 27 and 45. 9 goes into both of those. 9 goes into 27x times, 3x times. 9 goes into 45 5 times. Did I do it right? Yep, these are the same. Those have to be identical. So we'll pull out the 3x plus 5. And what does it leave us with? X plus 9. X plus 9 equals 0. Now it's equal to 0. The product of two boxes is equal to 0. 3x plus 5 equals 0. X plus 9 equals 0. Minus 5. 3x equals negative 5 divided by 3. X equals negative 5/3. And subtract 9. X equals negative 9. Numerical order, negative 9 before negative 5/3. Oh yeah. Now we're getting good. Now we're cooking with gas. Oh, in the answer key, they did not put it in numerical order. How dare they? Bad. Okay, so 1. Is it set equal to 0? This was not the problem. I still know it's coming. But notice, common factor. Oh, there is a common factor. We can factor out of 5. And so this problem that we have to factor becomes much smaller. So now we're just going to factor this. We will go through those little techniques. Special case, is it a binomial square or the difference of square? And remember, both of those have perfect squares. The first and so are both the first and the third perfect squares? No. So it's not going to be a special case. So we're going to have to use A times C. And remember, we're only factoring inside the parentheses at the moment. So my A is 1, my C is negative 3. What's the only way you can get a negative? Is when you multiply a negative and positive makes a negative, or a positive and a negative, which makes a negative. So I know when I do my factors of 3 that the signs are going to be different. And I look here and my indicator tells me that the bigger is going to get that sign, positive. So that means the smaller gets the negative, because negative 1 times 3 gives me negative 3, and negative 1 plus 3 is 2. Does that equal my middle? Yes, it does. That equals my middle term. So I'm going to keep that 5 out there. I'm going to break this down. I'm going to break this middle down into these two values. So that's negative x plus 3x minus 3 equals 0. And now I'm going to factor by grouping. And I'm going to keep that 5 out there. I'm actually going to do this. So if I factor these pairs, what can I factor out? I can factor out an x. If I factor out an x from x squared, that gives me x, and x from negative x leaves me with negative 1. That was tricky. And what can I factor out of these two? I can factor out a 3. If I factor a 3 from 3x, that leaves me with 3. And if I factor, which is division, factor a 3 from negative 3, that gives me negative 1. And so, did I do it correctly? Yes, I did. So let's keep that 5 out there. Let's pull out that x minus 1. And what does that leave me with when I pull out that x minus 1? It leaves me with x plus 3 equals 0. Now, this time, I have 3 numbers, or 3 boxes that equal 0. I have this box times this box times this box equals 0. This one has a variable in it. This one has a variable in it. This one I do know. I know that it's a 5. So this is a constant. What do we know? Can this equal 0? No. It equals 5. This is a 5. It's not an unknown. So now the only 2 boxes that can make it 0, remember one of these 3 has to equal 0. It's either this is 0 or this is 0. We know this isn't 0 because we know what it is. It's a constant. So when I go and separate each of these, it's just these 2 that have the ability to be the 0. This is 5. We know what it is. We just don't know what this is. What value for x would make this 0? What value for x when added to 3 makes this 0? So add 1, x equals 1, minus 3, x equals negative 3. My solution set is negative 3 and 1. Those are the 2 values, when plugged back in, would make that left side equal to the right side, which is 0. Oh, baby, you are learning so much today. Oh, you think that's hard? Oh, my goodness. Mr. Mack, look at all those variables. What's a big indicator? What should we notice first with this? I notice all the variables. Okay, yes, you notice all the variables and it's intimidating. But what's another thing that you notice about this that is uniquely different? There are 4 terms. Yes, there are 4 terms. 1, 2, 3, 4. Where else have we seen 4 terms in a problem? 1, 2, 3, 4. And when we have 4 terms, what technique do we use? Factor by grouping. Yes, very good. We are going to factor by grouping. Let's check it out. What's the common factor of the first 2 pairs? A. If we factor out an A, we get A minus B. Let's look at the second pair. What do they have a common factor of? C. Very good. If we factor out a C, we get A minus B. Do we get it correct? Did we do it correct? Yep, because these are the same. Let's factor those out, A minus B. And if we take out the A minus B, that leaves us with A plus C equals 0. Now, we can still set each one equal because we know that it's the product of 2 boxes. So A minus B equals 0. Let's solve for A. We're going to add B. Is that where they want me to go? It'll be interesting to see if I'm going in the right place. Yes, it is. A equals B. That's one of the solutions. And then we have A plus C equals 0. Let's solve for A. And we get A equals negative C. So my 2 solutions are B and negative C. Those are the 2 values for A that would make 0. If we plug in B or negative C, we would get 0. Ho-ho! Look at that. That would be crazy when we can plug those in. If we plug B in for A, so we're solving for A, solve for A, we would be able to do it in that manner. Wow, that was super crazy. All right, now I told you it was coming, set equal to 0. So we have to get rid of that 16 on the right side. So we would subtract 16 to get rid of it. And we get x squared minus 6x minus 16 equals 0. Notice on the left I put in standard form. 2 is it in standard form? Yes. Oh, 2 is standard form, sorry. 3 is common factor. Is there a common factor? Nope. 4 would be special case. Is it the difference of squares or binomial square? Ooh, it is, but it's not. Oh, so when we go through the test, it would not be a binomial square because we'll do that later. So 5 is A times C. We're going to use the old lovely A times C, and A times C will work well, not every time, but it'll always catch the special cases. So special case is sort of, can I save myself a little bit of time with a handful of problems? But if you don't see that it's a special case, it'll be caught in A times C. So don't worry about the special case part. A times C also factors properly. So A times C. A is 1, C is negative 16. That gives us negative 16. Factors of 16, 1 and 16, 2 and 8, 4 and 4. My signs are going to be positive and negative. They're going to be different because that's the only way I get a negative. And then I'm going to cheat by going here. That's my indicator. The bigger number is always going to have that sign. So 16, 8, and 4 get the negative. And the other one, they have to be different signs. Mr. Mack, why'd you give that 4 the negative and not the other one? Well, it doesn't matter because of the same number. 1 and negative 16 is negative 5. 2 and negative 8 is negative 6. 4 and negative 4 is 0. Which one equals my middle value? Is negative 6. So I'm going to take these two values to produce my new middle. X squared plus 2x minus 8x minus 16 equals 0. Factor by grouping. We're going to factor out an x. You get x plus 2. We have to notice my first term is negative. First is negative, so I have to factor out a negative. So 8x and negative 6, I'm going to factor out a negative 8. And that gives me x plus 2. The way that we always can check it is by redistribute it back. Do we get that term? So if we redistribute it out, did I get negative 8x minus 16? Yes, I did. So did I do it correctly? Are these two the same? Yes, they are. That is x plus 2. If I take that out, I get x minus 8 equals 0. Set them equal to 0. X plus 2 equals 0. X minus 8 equals 0. Minus 2. X equals negative 2. Plus 8. We get x equals 8. And I'm going to write the solutions. Negative 2 and 8 are my two solutions. Very nice. Complete the square. My bad. I just did that problem incorrectly. But we notice that we can set it equal to 0. Okay, let's go back to the instructions. There's the second mistake that Mr. Mack has made today. Sorry. So let's add a page. Let's take this problem. Let's copy that. Let's paste it. It's a lovely Friday, and I'm making videos at 4:35 on a Friday because I love my job and I like math, which is definitely part of my job. All right, so complete the square. So completing the square means that this time we actually want the constant over here, because let's talk about binomial squares. So binomial squares, we remember this is a binomial square, and that produces this times this. Whoa. And that produces x squared plus 2x plus 2x plus 4, which equals x squared plus 4x plus 4. Now you could have used the template. Remember that template was a squared plus 2ab plus b squared. And it would have produced that. But we're going to do this out because I want you to see that we are going to be doubling this a times b, this a times b, because x times 2 gave me that 2x. And we're going to get even more sophisticated. Let's do x minus 7 quantity squared. That's going to be x minus 7, x minus 7. And we get x squared minus 7x plus 49. And we get x squared minus 14x plus 49. And we again notice that we have this x times negative 7, and we have it doubled. X times negative 7 doubled, 2ab. That middle is always going to be the doubling of the a times the b value. And do you notice where we can also find this square root is always going to be this square root is always going to be this. So we can kind of know what we want to see on the outside and what this. So if we take half of this, that's going to be 7x, and that is that product. So that doubling, divide by 2, and that's going to be that product of it. All right. Now let's get even harder. Let's do it even harder. So what if we have 2x minus 3? Let's do plus 3 quantity squared. So that's 2x plus 3, 2x plus 3, and that's going to give me 4x squared plus 6x plus 9, which is 4x squared plus 12x plus 9. Notice 6x, this is a doubling of 2x times 3 is 6x. So it's a doubling of that product. I don't know if you see that or you see what I'm doing. So if I'm going to find out what that value needs to be in order for it to be a binomial square, what we do is we take half of that, which is negative 3, and then we're going to square it. That would be 9. So 9 would make this a binomial square. It would make it x minus 3 quantity squared. Because x minus 3 quantity squared would produce this. Where did I get the minus 3? From right here. That's my little cheat code again. But I put that 9 came out of nowhere. So I added it to the left side. In order to keep it balanced, I got to add a 9 to this side also. So this is actually going to equal 25. And it says complete the square to rewrite the equation, then solve for the zeros. Now that's interesting because, and we know what the solution is because we've already done this problem. It was negative 2, I'm moving the wrong thing, negative 2 and 8. So how else? I talked about how we could also solve this by solving for the variable. So you see what we have here. We have the quantity x minus 3 quantity squared equals 25. I can't get to that x yet because it's being squared. Kids, how do I get rid of a square? By a square root. Yes. Very good. So I have to take the square root of both sides. When I take the square root of a variable being squared, I have to introduce a plus or minus. Why? Because we know negative value squared is going to be the same as a positive value squared. If I have 5 squared and negative 5 squared, we notice that they produce the same numbers. So what could have produced that 25? It could have been a -5 or a +5. We don't know. It could actually be both. So we're going to introduce plus or minus 5. And the square root, these are going to cancel. That square root cancels with the square. And that's why we did this in the first place. I'm going to make that in this color. So that leaves us with x minus 3 equals plus or minus 5. I'm going to solve for the variable. I'm going to add 3 to both sides. Now, slow down. That says 3 plus or minus 5. So we need to understand what that means. It means it can either be 3 plus 5, or it can be 3 minus 5. 3 plus 5 is 8. 3 minus 5 is -2. Oh my goodness! Those are the same solutions. So you can solve it through setting equal to 0 and doing a times b, or you can complete the square and then solve for the variable by taking the square root. One of the things you need to remember is you got to introduce that plus or minus 5. Let's put that part in blue. And that's the tricky part. And what does that represent? So let's see the next one. Let's do another problem. Complete the square to rewrite the equation. So remember, I got to move that constant over. So I'm going to move the 12 over. I'm left with x squared plus 4x equals 12. Now, what value is going to go in there? I'm going to take my b, I'm going to divide it by 2, and I'm going to square it. So I'm going to introduce 4. So what I do to one side, I also have to add 4 to the other. So the reason why I did this was because this produces a binomial square. So I take the square root of that, and I take my value inside here, and that's a positive. And then 12 plus 4 is 16. And now I'm going to take the square root of both sides, because I got to get rid of that square. When I take the square root, that cancels and leaves me with x plus 2 equals plus or minus square root of 16 is 4. Whoa, that was so cool though. Minus 2, we get x equals -2 plus or minus 4, -2 plus 4, and -2 minus 4. So that equals 2 and -6, -6 comma 2. And look how fast that was. Could we have done a times c and gotten the same two values? Yes, you could have. There's also a third method called the quadratic formula. Opposite of b plus or minus square root of b squared minus 4ac all over 2a, which I'm sure we will be getting to in all good time. All right, complete the square, rewrite the equation, then solve for the zeros. Let's move the constant. Gives us x squared minus 24x equals 25. Let's take half of -24, which is -12, and let's square it, which equals 144. So we're going to add 144 to both sides. This produces a binomial square, x minus 12 quantity squared. That value always goes down into here, and my coefficient is going to be x squared equals 169. Okay, now let's take the square root of both sides. Square root of both sides. This gives us x, I don't want blue, x minus 12 equals plus or minus 13. I think that's 13. I should know. I just told you you should know your perfect squares. Bingo. Let's add 12 to both sides. X equals 12 plus or minus 13. 12 plus 13. 12 minus 13. 25, Mr. Mac, and -1. we write our solution sets in numerical order. Do you hear me, academic decathlon? We write them in numerical order. Okay, complete the square and rewrite the equation. Okay, that's all right. So it's already, our constant's already over there. So we're going to take half of 8, which is 4, and we're going to square it, which equals 16. So we're going to add 16 to both sides. This is a binomial square, x plus 4 quantity squared. Remember that value comes in. If it's positive, this is positive. If this is negative, this is negative. So that's good. And 20 plus 16 gives me 36. Let's take the square root of both sides. And that introduces x plus 4 equals plus or minus 6. Minus 4, minus 4, x equals negative 4 plus or minus 6, negative 4 plus 6, and negative 4 minus 6, we get 2, and negative 10. My solution set is negative 10, 2. Groovy. All right, now let's go up to the warm-up. Whew. This has to be more than an hour. What two numbers have a product of 56 and a sum of 15? So what two numbers? So x times y equals 56 and x plus y equals 15. We're not going to think about it. You're not going to go through. I guess you could, but I mean, maybe you could. You could do the factors of 56, which are 1 and 56, 2 and 28, 3, no, 4, yes. Ooh, that's a funky one. 4 and 16, 5, no, no, 7 and 8. No, I made a mistake somewhere. I think, yeah. I don't think that's, I think that's 14, 4 and 14, sorry. And then 7 and 8, that makes sense. Okay, so those are the two products. They product and the sum of 15, so that would be 15. So I guess you could do it in that manner. That's relatively easy. I guess the other way, mathematically, what I was doing here is you could, let me do this, xy equals 56 and x plus y equals 15. We can solve for x by subtracting y. X equals 15 minus y. And then we can plug this in for x. So you have 15 minus y times y equals 56. And that gives you 15y minus y squared equals 56. And then we can set it equal to 0. Yeah, this is way too long. But mathematically, this is what we would be doing. Ooh, that's equals 0. Negative y squared equals negative 15y plus 56. We can move the y squared. And notice I set it equal to 0. It likes doing that today. Y squared minus 15y plus 56. And so we set it equal to 0, and my first term was positive. So we can do a times c, which is 1 times 56, factors of 56, 1 and 56. And you notice that we end up doing something similar to this. And we're just intuitively smart enough to know. So, I don't know, you can do it either way. What two numbers have a product of negative 40 and the sum of negative 3? Ooh, so x times y equals negative 40, and x plus y equals negative 3. So we can again think of factors of 40, 1 and 40, 2, 20, 3, no, 4 and 10, 5 and 8. And now, if we have the sum is equal to negative 3, We know the numbers aren't the same. We know the bigger must be negative, because if the signs are different, and we know that they must be different because that's the only way you can get a product equaling negative, we know that the negative has to, because this is our leftovers. We have more negatives than positives. So the bigger gets the negative, and then this would be positive, and we already see our solution. Negative 39, negative 18, negative 6, negative 3. So I know my two numbers are negative 8 and 5. Our two numbers, when multiplied, equal negative 40, and when add up to negative 3. How smart are we? So x times y equals 12. X plus y equals negative 13. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Products, so they're either both positive or both negative. Since they're going to be the same sign, two numbers that are the same to add up negative means they both have to be negative. Negative 13, and that's my numbers. So it is negative 12 and negative 1. That's a nice little trick. What number, when added, would make a perfect square trinomial? So remember, this is my middle. It wants to know what would make. So we take half of 6, which is 3, squared is 9. So we would add 9 to both sides. So what number, when added, would make a perfect square? 9 would be the number that we would add to that to that expression. What number, when added, would make a perfect square trinomial? Ooh. So here's a little bit of a tricky part. Do I want to factor out? Okay, let's technically, if it's going to be a binomial square, if you're going to complete the square, you would factor out that 4 and then play the game. So half of 2 is 1, 1 squared equals 1. So you would add 1, but that's in this case. I would have to redistribute this back out, and we would notice that it would have to be adding 4. So that's a little tricky. So that's the trick way to do it, where it's super easy, where you can still use the completing of the square, and I didn't do it right. What didn't I do right? If I distribute it back, wait. Oh, no, 2. 2 divided by 2 is 1. 1 squared is 1. I think they made a mistake. Did they make a mistake? Because they say the answer is 16. Perfect square. So they say it's 16. So let's look. Let's factor when they say it's 16. So that technically would be 2v plus 4. Quantity squared. And that would not, they made a mistake. They made a mistake. Because if you do that, that's 2v plus 4, 2v plus 4. And that would produce 4v squared. That would be 8, and 8 is 16v plus 16. So that does not, my way is correct. This is the correct answer for number 5. Oh yeah, I'm good. I caught a mistake. Good. All right. What number, when added, would make a perfect square trinomial? Oh yeah. So here's the one that we've been waiting for. What's different about this problem than all the other ones? I'll give you a second, even though it's probably been an hour and a half. It's 5 o'clock now on a Friday. This is odd. Ooh. So when we take half of it, it equals 7 over 2. And we square it, that's going to equal 49/4. So that's what we have to add to both sides. Ugh, ugly. Not fun, but super easy. So 49 fourths is the easy, super easy answer. So don't be intimidated when the middle term or b is odd. It's just as easy. You put a 2 under it. If you can simplify it like these. You can simplify 2 over 2. Or if you can't, just square it. Square the numerator, square the denominator, 49 fourths. We are done. Have a great weekend. Good luck. You're going to have to do a lot of extra work to be proficient at this. But I'm here.